Imagine this, you're drifting through the silence of space, when suddenly, you feel yourself being pulled, not toward a planet, not toward a star, but into a vast, dark abyss. Reality begins to twist. Time feels different, and your body? It starts to stretch. You're falling into a black hole. Black holes, the most extreme objects in the universe. Some are small enough to rival Manhattan. Others are so colossal, they could swallow 40 solar systems side by side. With masses reaching 100 billion times our sun, these monsters are beyond imagination. But here's the catch. Once you cross a certain point, what scientists call the event horizon, nothing can escape. Not you, not light, not even information. Or can it? That question drove me to call up world-famous physicist Dr. Brian Cox, because I had to know, what actually happens if you fall into a black hole? What would you feel? And what do the latest discoveries tell us about what's inside? Boarding the ship, so picture this. You and I climb into our imaginary starship. Unlimited speed, unlimited fuel. Destination: the black hole at the heart of our Milky Way, Sagittarius A. Scientists estimate it's 4.3 million times the mass of our sun, yet, if you placed it in our solar system, it would barely reach out to Mercury's orbit. Shockingly small considering its insane weight. And compared to others out there, it's middle-sized. Some dwarfs, like Ton 618, weigh 66 billion suns. Through telescopes, we can't see black holes directly, they trap light. What we do see is the accretion disk, matter spiraling inward so violently it glows brighter than entire galaxies. And here's the mind-bending part. The light bends around the hole, meaning we can see both the disk in front and the disk behind. Space itself is curving light into our eyes. Time splits in twano. As we fly closer, something deeply strange happens. From our perspective, we're coasting in freefall, weightless, nothing unusual. But if someone on Earth pointed a perfect telescope at us, they wouldn't see us falling normally. They'd see our clock slower, until they froze completely at the horizon. To them, we'd never cross it at all. Two journeys emerge. Ours inside, feeling time move normally. Theirs outside, watching us fade in slow motion, our light stretched redder, weaker, until we vanish. Einstein predicted this. Space and time are not separate, they're one fabric, space-time. And black holes warp that fabric to its ultimate extreme. Spaghettification's the horizon, and gravity spikes. Suddenly, the pull at your feet is stronger than at your head. The result? You're stretched long and thin as if turned into cosmic spaghetti. Atoms tear apart. Even quarks inside protons unravel. Until nothing remains. Just fragments of you racing inevitably toward the singularity, the place where space-time ends. And here's the kicker, the singularity isn't just a point in space. It's the end of time itself. Trying to escape a black hole is like trying to escape tomorrow. You simply can't. Wait, Hawking Einstein said black holes live forever. But Stephen Hawking threw a cosmic curveball. Black holes are not completely black. They glow, very faintly. They leak radiation, and will one day evaporate away. But there's a problem. According to physics, information in the universe can't be destroyed. So if black holes eventually vanish, what happens to everything that fell inside? You, me, the crushed stars? This is the black hole information paradox. The cutting-edge recent research suggests Hawking's first calculation missed a detail. The radiation might not be random. Instead, it could carry a scrambled imprint of everything that ever fell in. In other words, the black hole isn't erasing the past, it's re-encoding it. But how? No one knows for sure. Some theories hint the inside of a black hole is secretly connected to the outside. Maybe via quantum wormholes. Maybe space and time themselves are information woven together, like a giant quantum computer. Whatever the truth, black holes are clues, gateways to the very foundations of reality. The wonder, and here's what makes this astonishing. By studying these collapsed stars from galaxies away, we've started to glimpse answers about quantum computing, space-time itself, and the ultimate fate of the universe. Black holes force us to the edge of understanding. They're terrifying, impossible, beautiful, and yet, they fill us with wonder. So the next time you look up at the night sky, remember, hidden in the darkness are objects so powerful they bend reality itself. And incredibly, we can study them, dream about them, fall into them in thought. Black holes, the strangest, most wonderful things in existence.